Alright, so this is some stoichiometry problem samples that we're going to be treating right here in this video. Alright, so let's begin. Before I go forward, I would like to explain or give you a group of or some formulas that would help. Okay, so the first one is to search for the number of moles. And for the number of moles, this is equal to the mass divided by the molar mass. That is the first formula we need to put in mind. The second one is for concentration. So this is for concentration. Sorry, I'm going to say for solution. This makes it better. For solution, that's a liquid substance. I have the concentration multiplied by the volume. Now for the third one, I have for ideal gases. And this is PV over RT. Right? Let me make my over RT. PV over RT. Okay. For gases at STP is the next one. So the fourth one for gases at STP. This is gonna be the volume occupied divided by 22.4 dm cube, which is the volume of gases at standard temperature and pressure, and that is a constant that doesn't change. Now for number of particles, which is my last one, number of particles, and that's my number of particles divided by the Avogadro's constant. So that's the Avogadro's constant, and that is 6.02 times 10 raised to power 23. Okay, now I think I should write this properly for us to see. So I said to the 23, right? Okay, I've just given 5 formulas that is going to help us in our journey. Okay, so 5 formulas that will help us to solve questions regarding calculations in stoichiometry, okay, or in chemistry. All right, good. So let's look at this sample problem. This says that how many moles of calcium trioxocarbonate 4 are there in 2.5 grams of calcium trioxocarbonate 4? All right, so what we're looking for actually is to find the number of moles present in this compound, okay, if it has a mass of 2.5 grams. Okay, so let's solve down. Create a new space for myself. All right, so if I talk about the molar mass, this simply implies that I need to add up all the relative atomic masses of all the compounds that I have. Okay, and my formula is CaCO3. Okay, that's calcium trioxocarbonate 4. Now, for me to get this out, my calcium has an atomic mass of 40, plus my carbon has 12, plus my oxygen has 16. Okay, I'm going to be multiplying that by 3 because it comes out in 3 moles. and if I add this up together, it's going to give me 100 grams per mole. Great. So first step achieved. Let's move forward. Now for me to find my number of moles, it's quite simple. In my formula here, it says that for the number of moles, that means I'm going to be dividing the mass by the molar mass. And when I come down here, it asks me for the number of moles. So I already have my molar mass to be this. My mass in the question is 2.5 grams. So here, to follow my formula, I have 2.5 divided by 100 grams per mole. Okay, sorry. So grams per mole. And my final answer is going to be 0.025 moles. That is my final answer for the first question. You can see it's quite easy and straightforward. Let's take another example. Okay, so this question says, what is the number of hydrogen ions? Okay, number of hydrogen ion in 9.8 grams of tetraoxosulfate 6 acid solution. Okay, this is quite easy and straightforward, so let's take it up. Now, before I start, I'll need to make you understand that we are looking for the number of hydrogen ions. This is talking about a number of particles, all right? Because the ion right there is the particles. Now, if you look at my formula that I give you, I said for number of particles, it is the number of particles divided by the Avogadro's constant. Now, if I come here, I have what is the number of hydrogen ions in 9.8 grams of tetraoxosulfate 6 acid. Now let's get it straight up. First of all, we need to look for the molar mass of this. So the first thing is first, we need to find the number of moles. Okay, and the number of moles equals to mass divided by the molar mass. Okay, so this is what I have. Let me break it out. My mass, the mass of my H2SO4, okay, is gonna be, my hydrogen is 2 because I have 2 moles of hydrogen in that, plus my sulfur is 32, plus my oxygen is 16, and then I'm going to multiply that by 4. My final answer for the moles of my tetraoxosulfate 6 acid solution is 98 grams per mole. All right, so it's quite straightforward. Let's continue. Let me get this down here. So when you look at the question again, we are asked to find the number of hydrogen ion. Here, I already have my number, my molar mass for tetraoxosulfate 6 acid solution. So for me to find my number of moles first, which is my mass over molar mass, is going to be my 9.8 grams divided by 98 grams per mole. And this is going to give me a total of 0.10 mole. Now I've successfully converted this to my mole. Okay. Now that I have successfully converted that to my mole, I know that the dissociation of tetraoxosulfate 6 acid, which is H2SO4, would give me 2 hydrogen ion plus SO4 2 minus, right? And in this case, I know that 1 mole of my H2SO4 produces 2 moles of hydrogen ion. Here, I have 1 mole of tetraoxosulfate 6 acid. I hope you know this is a balanced equation. Okay, I have 2 hydrogen here, I have 2 hydrogen here, 1 sulfur here, 1 sulfur here, 4 oxygen here, and 4 oxygen here. It's balanced. So 1 mole of H2SO4 produce 2 moles of hydrogen ions for me. Alright, and I am looking for the number of hydrogen ion present in this solution. So we're opening it up. So since I know it is 2 moles, I'm going to be multiplying the 2 by the number of moles I got from finding my moles. Okay, let me erase this and write it properly. So I'm going to multiply it by 0.10 mole. Okay, if you don't remember the 0.10 mole, check it here. Okay, I got it here when I found the number of moles for the acid, and then my final answer, my answer for this is going to be 0.20 moles of hydrogen. Now, if you are checking it one by one from how I am doing it, my first step was to find the molar mass of the compound. The second step is to find the number of moles, which is the mass divided by the molar mass. The third step is to write out the correct and the balanced equation for the compound, and then I looked for the number of moles that made up the hydrogen ions I'm looking for. Alright, so from here now I have my number of particle, which is this, isn't it? Now in this state, I'm not going to be dividing it by the Avogadro's constant. Instead, I am going to be multiplying it. So I can actually tell you that 1 mole, okay, of the hydrogen ion would give me 6.02 times 10 to the 23rd, which is the Avogadro's constant. We know this, isn't it? Isn't it? Then that tells me that 0.20 mole of hydrogen ion will give me what I am actually looking for. Now, if I cross multiply these two, I'm going to be having my 0.20 multiplied by my 6.02 times 10 to the 23rd. And my final answer is going to be 1.2 times 10 to the 23rd hydrogen ion. Hydrogen ions. This is my final answer. Now let's take it back a little for us to see how it's solved. So what's the first thing I did? I found the number of moles, which gave me 98 grams per mole, and then I found the molar mass rather for the compound, and that gave me 98 grams per mole. I found the number of moles, which is mass over the molar mass, and then I got 0.01 moles. Then breaking it down into its dissociated form, that means that I broke it down to 2 moles of hydrogen and 1 mole of tetraoxosulfate 6. Okay, now what I have here is a balanced equation for the compound, and after breaking that down, from here I realized that this is 1 mole, and that gave me 2 moles of hydrogen ion here. It also gave me 1 mole of tetraoxosulfate here, but I have no business with this tetraoxosulfate since I was asked to look for the number of hydrogen ions it will produce. And so I know I have my 1 mole of hydrogen, my tetraoxosulfate 6, and it gave me 2 moles of hydrogen. The 2 moles is what I have here. So if I'm multiplying these 2 moles by the molar mass I got, it will give me this. And then all I have to do to get my final answer is to just multiply it by the Avogadro's constant. That's quite easy and straightforward. Let's take the next question. Now this one tells me to find the number of molecules of phosphorus that are present in 496 grams of the substance. Okay, now let's take a quick look at this question. My phosphorus is given to me here as P4, right? So the first thing I need to do is to find the molar mass of this P4. Okay, now what I'm going to do is quite simple. I was given my P to be 31. So to find my P4, this is going to be 31 multiplied by the 4 moles that it comes out with in. Okay, and this will give me 124 grams per mole. Now, this is easy and straightforward. But that's not all. Sorry about this. Sorry about that. I had to take the call. Alright, so here I have 124 grams per mole. Okay, now that's not all for the question. Let's move forward and see. So since I have the molar mass for my polyatomic molecule, which is this, the next step is for me to find the number of the substance, which is also talking about the number of particles. Okay, I'm going to write this as NP here. Okay, look, now that I have this, it's quite easy and straightforward. I know that 1 mole, okay, sorry about that. So I know that 1 mole of the phosphorus, that's P4, will definitely contain here 6.02 times 10 to the 23rd. That is the Avogadro's constant. That simply tells me that my final answer should be 6.02 times 10 to the 23rd multiplied by the 4 moles that this comes out in. Alright? And that is going to give me a total answer. Okay, that's going to give me a total answer of calculating this. Let's see. 2.40 times 10 to the 24th molecules. Easy and straightforward. Let's take another example. And this should be my final example, and we'll call it off for the day. Okay. So it says upon eating 1.25 grams of a solid, 280 centimeter cube of a gas measured at STP were evolved and a residue of 0.7 grams was left. Calculate the molar mass of the gas. And we're given the molar volume of a gas to be 22.4 dm cube. Okay, so it's quite easy. Let's solve and see. Now, if you look at the question properly, you'd realize that after eating the solid, okay, we got a volume of 280 centimeter cube of a gas to have evolved, isn't it? So what was left is unknown, but a residue of a solid. So that tells me that from this 1.25 grams, if I subtract this from 0.7, which was left, I would actually have the mass of my gas, isn't it? And this will give me 0.55 grams. These are simply giving me the mass of the gas. Now, I know that the volume occupied, okay, by the gas is 280 centimeter cube. Okay, now if I convert this to decimeter cube, I would have 0.280 dm cube, which is advisable that you do. And all you have to do is to just divide this by 1000 and you'd successfully convert it. All right, so now let's move forward. That tells me that 0.280 dm cube at STP, okay, yeah, occupied this 0.55 grams, which is what I have here. Okay, are you getting it? Now, I know that 22.4 dm cube at STP would then be equal to 0.55 right here. Then I'm going to multiply this by 22.4. Then I'll divide this by the volume occupied, 0.280 dm cube. Okay, then my final answer should be 44 grams. And this is the molar mass for the compound, for the gas. Thank you very much and have a lovely day. I am Lafex, and if you would like to reach me, you could reach me from damichael565 at gmail.com. Thank you and have a lovely day.